Okay, so I'm gonna repeat this part because there was some weird behavior in the character that happened during the lecture. Now, this is the same project, but for some reason this behavior doesn't appear anymore. So I'm just gonna repeat this part. Now, we were about to add the movement. We have seen, in the previous lecture, we added some movement to the object using the character controller. Now we're gonna try something else. We're gonna try movement, adding movement to the character through the rigid body. So we already added the rigid body component. Now we're gonna get into the script in order to, first we need to capture the user input. So if the user clicks the arrow keys, based on which key or which arrow the user clicked, we need the character move into that direction. So there is some common aspects here of like the way we created the movement with a character controller. First of all, we need to determine speed. So we can have this public float moving speed, and I'm making it public so that it would appear on the Unity editor so that we can experiment with it on the editor instead of having to keep going back and forth with the script. We also need to have the X input or the value, whether the user clicked the horizontal arrows, which we will map to the X dimension, and then there is the float. Now the Y direction in the scene here, you see the Y is up and down. So this is not what we want. We want X to determine back and forth like this. So the X determines left and right, and the Z is not seen here. So I'm gonna rotate the scene a little bit so that we can see it. And to rotate the scene, you click on the Alt key and click on the right mouse button. Okay, so Alt key and hold it, and then click on the left mouse button and hold it, and then drag so that it will rotate with you. Now see, the Z goes like this in one direction, and then the X goes in the other direction. So now you can see the X. This is the dimension of X, and this is the dimension of Z. Y is up and down, which is not what we want. We want our character to move on the ground. Okay, so we want X, and we wanna direct the movement based on changing the value of X and Y. X and Z, not Y. So Y remains 0. All right, so instead of Y input, I say Z input, because we're gonna take that input and translate it into movement on the Z direction, okay? And we are going to use the rigid body, so we're gonna need access to it. So I'm gonna just create a reference to the rigid body, and in the start, I'm going to get the pointer to the component that is already attached to the object that we attached this script to. So you see the object has a component that is rigid body attached to it. Also, this script is attached to the same game object, okay? So now we're just having this pointer point to the game, the rigid body component that we attached to the robot object. All right, now we need the input from the user. And the input from the user we get through the input class. So input dot get access, and if we want the horizontal axis, so we write horizontal, and that's what we are going to map to the x dimension. So this get x is horizontal will give us 1 or 0 or -1, depending on whether the user clicked on the right arrow key or the left arrow key. If the user didn't click on the either right or left arrow keys, this value will be 0. So x input, this is where we receive the left and right arrow keys, whether which one or whether either of them was clicked. And for the up and down arrow keys, we are going to receive them in the Z input. So again, through the input class, we get axis. And the axis that we are interested in is the vertical axis. That is the up and down arrow keys. Okay. So, okay, it seems that. All right, so now how are we going to translate this into movement? First of all, this just gives you 1, -1, or 0, okay? So this gives you direction. So in order for that direction to translate to an actual movement, we need to add some units to it. So we're gonna use the moving speed in order to determine how much movement when the user click on one, like click once on the arrow key. So that would be x input multiplied by moving speed. Okay, now the y input would be 0, still 0, because we don't want it to move up and down. Now the z input, or the z of the direction, so this is the x of the movement, this is the y, and the z would be the z input multiplied by moving speed. All right, so this is we can create a vector 3 based on these coordinates, right? To determine how the character is gonna move. Now we said we're gonna use the rigid body for the movement. Now how can we do that? We can just say RB dot add force. So the add force function in the rigid body is how we introduce movement, and we can send it the 3 coordinates x, y, and z. So the x, as we mentioned here, is the x input multiplying by the moving speed. Y remains 0, and z would be the z input multiplied by the moving speed. All right, now let's see if this is gonna work. All right, I'm gonna run this. All right, so let's move back, forth. Now we see how it turns first to the direction it needs to move to, and then now we see what happens when it goes over the edge of the ground. Because of the rigid body, it just keeps falling, right? So let me just make it fall here in the scene as well so we can see it. Now let's see, it falls down. Now we can use the scene manager to reload the scene. You see, this is a scene, right? So we can use a scene manager to reload the scene whenever the object falls down. So how do we know that the object falls down? Now we know that y dimension is the location of this y-axis, the transform dot position dot y will let us know where the object is on the y-axis. Okay, now we know the ground is at is at 0, so anything below 0 means it's falling off the ground. Okay, Now we can make it fall a little bit before we decide that we are going to do something about this failure, this falling. So now we can see, okay, now how do we know the position of the object? Now the position is the object is part of the transform component. All right, so the position, if we say transform dot position dot, now we can say X, Y, or Z. Now the Y is what we are interested in. Oh, not parent. Position dot, it can be X, Y, or Z. So Y is what we are interested in. Now, if that Y is less than or equal to, so let's say we let it fall a little bit before we do something about it. So we can say less than or equal to 5. And it is supposed to be float, so we turn it to float. Now, what are we gonna do? We can use the scene manager. There's a class called scene manager that allow us to load a scene. So we can reload. We only have one scene at this point. So that scene would be the scene of index 0. So we can reload that. So we can, if we say scene manager dot load scene and give it the index of the scene that we want, it will reload it. Okay, so now we only have one scene, so it would be at index 0. Now in the next video, you're gonna see how to add other scenes, and you can change that index to load another scene. And that's how you give the impression of having moving to a different level. Okay, so let's save that and go back to Unity and see how is this gonna work. Now I'm gonna run. Okay, I'm done. Something was wrong. Oh, now we see we said y has to be below 0 in order to know that it is falling, right? So it should be less than or equal to 5. And then we reload the scene. I mean, minus 5, so it has to be negative. Now let's make it fall. There you go. So every time it falls, it reloads the scene. All right.